And of any energy audits, findings, or information you might get out of them, one of the more important things is to identify air leakage and address it prior to blowing insulation. There's a lot of misinformation out there that insulation by itself can improve energy bills 20 to 30%. That's really not the case unless you've gone underneath and done all the prep work that we've been doing, foam sealing all these air leaks first, because insulation is merely an air filter. It's not an air barrier. And as you see with this dirty insulation here, air will still move through it, and as it does so, the insulation will act like a filter, trapping this pollution, pollen, mold, mildew, other sawdust, and building byproducts within it. Of course, this air leakage drives thermal inefficiency in the house, provides for convective pathways for heat loss, and then also drives indoor air quality concerns because you don't want to be breathing the stuff that's up here. You can see where most of this insulation gets moved out of the way, and we gain access to some of these leakage areas to spray foam them to tight up. Most of that work will usually recover its cost within a 12 to 18 month period, and is a vital, if not necessary, step when you're thinking about adding attic insulation to make sure that you do this first. One of the most important steps here is to seal up the top plates, and what you have below me is a small uncovered section of where we sealed yesterday. This top plate is the very top, literally, of an interior partition wall, and I can stand on it. It's load bearing. The drywall itself was installed to one side of the top plate and then another to the other side, and so what you were left with was gaps along both sides here that were air leaks. And what we've done here already is gone through and spray foam and put the spray foam nozzle down into this area to seal it all up. Very effective way at removing top plate leakage. Behind me here on the right is the top of a recessed can light cover. It's a little plastic extruded piece that we fit around insulation contact rated lights. Builder grade recessed lighting in many old homes still leaks a tremendous amount of air, especially when you start racking up the number of recessed lights. When some of our new houses have got 10, 15, 25 recessed can lights that all allow 2 to 3 square inches of leakage through them, so that adds up quickly. If the can light's been rated for insulation contact, we can fit this plastic piece on top of it, basically stopping all the air leakage around it. It's foam sealed to the bottom of the drywall and stapled down so it's not going anywhere. Now we can just put cellulose or more insulation right around on top of it. To my left over here we have a different type of recessed can light, and the retrofit that we call this is a AT box for airtight box. This recessed can light was a halogen style fixture, and per building code you must have at least 3 inches of void space, dead space, around such a hot fixture to the nearest building material. So instead of installing those plastic covers as you saw on the other side of the house for the insulation contact rated light, for non-IC lights we built a little airtight box at a drywall and spray foam, so you got a little sealed compartment that won't let any air infiltrate or exfiltrate from the building shell. Now on the front of the house we have what are called polystyrene vent chutes. We install these prior to blowing attic cellulose to maintain proper attic ventilation. And these chutes are designed to hold open an air channel that starts down at the soffit and will basically let outside air equalize temperature with the attic. I'm standing on top of a pull-down staircase, and the energy shield's designed to slow some of the attic air infiltration in and outside of your upstairs building shell by having this R11 sort of foil-faced foam installed in this little tent area. And the tent has got a zipper access, so that when you need to get in and out of it, you just unzip it, you push the flap across, and you can get up in the attic space. And this is a really easy way to insulate and gasket these pull-down stairs, which are some of the leakiest types of things, or bypasses in general, in and out of an attic space. As you see, we've got insulation and specifically blown cellulose material blown throughout the attic. This was sort of a coup de grace step as far as all weatherization goes, because now that we've got it up here, we've got between 17 and 18 inches. We blow a little bit extra on top of R50 in case the insulation settles down. You see how much more difficult it would be to move or gain access to different sides of the home. This is a great material. It's made out of recycled newspapers and cardboard, and it's just shredded, and it's actually very safe. You can hold it if you like and not have any danger of putting this stuff into your skin like you would a fiberglass. And the material itself, the cellulose fibers, are treated with a fire retardant chemical called borate, and the borate is a fire resistance product that will actually not ignite. And furthermore, that borate chemical, which is for fire retention, is also for some reason undesirable for little critters to nest in it. So Unlike fiberglass, raccoons and squirrels and mice prefer not to burrow through the cellulose and live in it because of the borate chemical. So it's got that added benefit for it as well. It's a green product. It's made out of recycled newspapers and cardboard. You really couldn't ask for much more out of an insulation. The nice thing also is that it's such a fine fiber that it gets down in all the little nooks and crannies between old bats of insulation, around skylight shafts, and it's very easy to install. So it does a very effective job at creating an excellent thermal barrier, and with the air barrier that we created by foam sealing and all that other work, we're going to show a substantial amount of savings for this household.